100101, beep boop. Let's learn the fun-sized story of counting systems and Polynesian binary. Early in our wee years, as any parent can tell you, one of our first forays into humanity becomes an obsession. The day we learn that we can dazzle our elders with sequence recitation. We have two choices, and more often than not, though the ABCs are delightfully set to song, we opt to use the visual aids right in front of us. 1, 2, 3. This numerical sequence allows us to quantify scoops of ice cream, quantify how many more toys Jenny got on Christmas than me. Not fair. Later, we will use machines which manipulate these numbers to create moving images in light boxes, and occasionally curse at preteens on the other side of the world for murkiness in Call of Duty. Consider if we could pluck one of our Cro-Magnon ancestors from the annals of time and drop them into our living room. We might imagine that they would fall to their knees as we fire up Hulu on our smart TVs, awestruck by the sorcery, ready to worship the all-powerful holder of the remote. Or would they? Biologically, we are the same beings. Same brain size, same capacity for crunching numbers and abstract thought. After all, isn't TV just moving cave paintings? We have our answer on a small island, where ancient subsistence farmers may have been uniquely prepared to excel in the information age. Back to counting. Our modern system is based on the number 10, and at least for most Earthlings, the measurement system is based on powers of 10. But using 10 as a basis, or the decimal system, is just a convention, likely due to our attached counting tools. Other systems are based on 20, possibly due to our other set of tools. These systems are known as vigesimal, from the Latin word for 20, and are not uncommon either. In Europe, before Julius Caesar came, saw, conquered modern-day France, the Celtic language spoken there used a base 20 system. Hence, 99 in modern French is the lengthy 99, literally 4 20s, a 10, and a 9. The Aztecs and the Maya also used base 20 systems, and they created the most advanced calendars in history. So, taking an hour to say 99 aside, maybe the French weren't too off base? You like that? There are also binary systems, which means using only two numerals. The German mathematician Leibniz demonstrated in the 1700s that using such a system would simplify mathematical calculations, and he denoted the numerals as ones and zeros. Does that sound familiar? That's because binary systems are perfect for computers. To give the quickest and possibly flawed rundown of computer science ever, 1 can correspond to a closed circuit, or on. 0 can correspond to an open circuit, or off. This translates to true and false. These can also denote letters and numbers, allowing a machine to execute a series of commands, or an algorithm, and so on until we're all just human batteries for our robot overlords. There's no rhyme or reason for what base to choose, and one example of unique counting systems are in the languages of Polynesia. Most of these languages made use of a decimal system, with specific items being counted in pairs. On Tahiti, breadfruit and coconuts were counted in pairs, whereas on Hawaii, canoes and tapa cloth were counted in pairs of pairs, or in fours. This is not so counterintuitive for English speakers. If I asked you, how many shoes do you own? You would likely answer me that you own 3 pairs, which is actually 6. Some of you only have 3 pairs. We also have evidence that Polynesians thought in terms of exponents. For example, the word for 100, or 10 squared, teao in Tongan, rau in Tahitian, becomes lau in Hawaiian, meaning 400. This indicates that Hawaiians adapted their concept of pairs and multiplied the base squared by 4. This type of sophisticated mathematical thinking reached its peak on the island of Mangareva. There, we see an adaptation of a binary system mixed with the traditional Polynesian decimal base. Similar to the Hawaiians, Mangarevans counted in powers of 10 multiplied by 2 or powers of 2. For example, the number 400 would be conceptualized as 5 80s. In other words, 5 units of 10 times 2 to the third power. We also see predetermined counting bundles, as on other islands. On Mangareva, turtles were counted as 1, but 4 coconuts made up 1 unit, as did 8 octopuses. So 10 units of octopus was actually 80. You might notice those numbers are also powers of 2, and likely developed from extending the concept of multiplying pairs. The need to keep track of large amounts of items could have been due to a highly socially stratified society on Mangareva. The upper class and kings not only needed to know how many items they possessed, but since they projected their power by giving gifts at feasts, it was important to know that they had gifted more than their peers. Flipping our previous example, on Mangareva, if Jenny knew that she got and gave more toys on Christmas than me, it would make her more powerful and more important. Leibniz, while describing his discovery, also outlined the shortcomings of a binary system, the most of which were long strings of ones and zeros, which easily get confusing. The Mangarevan innovation of mixing a binary system with a decimal system appears to have solved for this problem centuries before Leibniz. Sadly, this traditional system was lost with the transition to European numbers during the French colonization, who also introduced their weird vigesimal numbers. Most of what we know is only pieced together conjecture from colonial accounts. But Leibniz's discovery of binary calculation laid the foundations of modern computing. So if we plucked one of our Mangarevan ancestors out of history and dropped them into a Google internship today, they might not be as out of place as you'd think. Remember, history isn't just kings and dates. It's the story of me and you, just in different times and different circumstances. One big soap opera, and we should learn it that way. I know I'm becoming a broken record, but please, like and subscribe. Follow me on Instagram, join the conversation on Reddit, and consider becoming a patron at patreon.com. For playing on your iPhone all day, it's okay to say you're welcome.